Okay, question 636. Smallest element larger than target. Given a target integer t and an integer array a sorted in ascending order, find the index of the smallest element in A that is larger than t, or return -1 if there is no such index. So the function smallest element larger than target, there are two input data in this function. The first one is an array and the second is an integer for the target, and the return type is an integer to indicate the index of the smallest element larger than the target. So the assumption here is that the input array is sorted in ascending order and they can be duplicate elements, and the corner case is when array is null or the length is 0. When that happens, we return -1, and the solution here is binary search plus the post process. So now looking into the code, the first part is sanity check. First, we check if the array is null or not, and second, we check if the length is 0. If any of these happens, we return -1. And next is to set out the pointers for the binary search. Left is 0, right is array.length -1, and these two pointers define the search range. And next is the while loop. The condition of the while loop is left less than right -1, meaning when there are only two elements left in the search range, then we don't go into this while loop and we use the post process to see which element we should take. And we're not doing this because we try to avoid the dead loop. Okay, so now looking inside the loop, first we calculate the mean index and then we compare the mean element to the target. If the mean element is less or equal to the target, meaning the target we're looking for are in the right side of the array, then we move the left pointer to mean +1. Otherwise, we moved right to the mean. Okay, and at the end, when there are only two elements left, then we get out of this loop and then we do the post process. In the post process, we first check if the left element greater than the target, then we return a left. If not, then we check if the array right element greater than the target. If yes, then we return right. If not, that means there are no elements greater than the target, then we return -1. So the time complexity of this function is log n because we use the binary search. In each iteration, we reduce the search range by half. And the space complexity is O1 because in each iteration, we don't create a new variable or new object. Okay.